Everybody, and thank all of you. And we have over 100 people online as well, so we have a pretty big audience, which I think speaks to how interested everybody is in the topic that we're addressing today, which is how to analyze longitudinal dyadic diary data. It gets very complicated very fast, so we're really looking forward to hearing from some of the leading experts in the field today. Today's panelists are at the forefront of the work that's going on in this area. We're happy as the Texas Center on Aging and Population Sciences to host this event, and I want to welcome the folks who are online as well as the people who are in the room. Before we get started, I wanted to send out a special thank you to Hewan Che, who organized and is moderating the event today, and just, you know, she's gone beyond the call of duty to make it all happen, pull it together. And I want to thank Rita Stramel for helping to organize today's event, as well as Ewen, Jamie, and Sarah, who are also who played a big role in putting it together. So I'm going to hand the reins over to Hewan now. She's going to lay out the agenda for today, introduce our speakers, and moderate today's discussion. I look forward to hearing everybody's comments and questions as we go throughout the day. Thank you. I forgot to introduce myself. Oh, well. You can introduce
Hi, everyone. Thank you so much for coming here this morning. My name is Hewan. I am a postdoc working at UTPRC. And we have like three panelists, amazing panelists today, who will talk about the theories and applications of analyzing longitudinal dyadic data. And after all these three presentations, we will open up the floor to have Q&A. So please, if you have any questions, please save your questions until the end, after all three presentations are finished. And for those of you who are joining on Zoom, if you have any questions, please enter your questions on chat box, because we will be monitoring them during the Q&A session and bring up the questions during the session. So now I would like to introduce you to our first panelist, Dr. Thomas Lederman. Dr. Lederman is an associate professor in the Department of Human Development and Family Science at Florida State University. And he will give us his talk on analyzing longitudinal dyadic data in multi-level modeling and structural equational modeling frameworks. So please welcome Dr. Lederman.
Right, thank you very much. It's a great pleasure to be here. Thank you for the invitation. I'm happy to talk about the analysis of longitudinal data using structural equation modeling or multi-level modeling. My talk has three parts. Why dyadic longitudinal models? So that's the first part. It's relatively short. Then in the second part, I will talk about longitudinal models for dyads. This is the longest part. And then I will briefly talk about advantages that I see that structural equation modeling and multi-level modeling have. I will also briefly talk about advantages that these two methods have when we talk about specific models. All right, so we will start with the question, why do we need dyadic longitudinal models? So models that are specific for dyads. So the analysis of longitudinal data from dyads calls for specific techniques, because there are two types of non-independence with longitudinal data from dyads. And the first is, within dyads, members are non-independent. Dyad members are more similar to one another than random people. And so this is one type of non-independence, usually reflected by a positive correlation. And the second one is across time, right? We have non-independence across time. This is also known as autocorrelation. And here's a quote from David Kenny and David Kashi, which I like. There is probably no more reliable finding in the social and behavioral science than the fact that best predictor for future behavior is past behavior, right? So this is what we can understand about autocorrelation. And now what's also important is that standard methods for multi-level data are not appropriate for diets because the group size is only 2 in diets. So that's the reason, right, why we need specific models for diets. And today I will talk about 6 different models. This is the stability influence model. I will start with that one. Then an extension, which is known as random intercept cross-lagged APIM. And APIM, this is the acronym for actor-partner interdependence model. Then I will talk about the dyadic graph curve model, which is another very popular model, latent change score model, common phase graph model. And then I will talk about what has become known as the LAPIM or the longitudinal APIM. So the stability influence model, this is kind of the APIM for 2 time points. And now you can see it's very straightforward to use the APIM, the standard APIM for 2 time points. So here it's shown for satisfaction measured in women and men. And this model is known as cross-lagged APIM. All right, so in this model, there is also kind of the after effect is the autoregressive effect and reflects stability, right? So we have stability of satisfaction for the man and for the woman. And the partner effect is the cross-lagged effect, and this reflects the influence, right? So in this model, you can feel relatively comfortable using causal language when describing the results. So this is the terminology that we can use for the stability influence model. So this model can also be extended to 3 and more time points. And with 3 and more time points, usually the adjacent time points are often taken as independent from the influence of previous time points. So when we use the language of mediation analysis, we would say there is no C prime path, or we could say, which would indicate full mediation. So what does this mean? This means, so time point 1 does not have a direct effect on time point 3. It has only this indirect effect to time point 2. So that's what this means. So you can see this is very straightforward, this extension. And with 3 and more time points, we can test different conditions. And we can test stationarity and equilibrium. So it kind of requires that we have a constant time interval. I think if we don't have a constant time interval, it does not make a lot of sense. And also no C prime path. So no direct effect from wave 1 to wave 3. So what does stationarity mean? So constant effects over time. So the autoregressive effects are constant over time. So the stability is constant for both members. And then also this cross-lagged or influence effects are the same over time. I mean, I don't say this is something we are looking for. It's something we could test. And for example, you may also have the assumption the longer a couple is together, or the longer the relationship in general, the stronger the influence from one partner to the other. That may be possible, right? So then it's fine if stationarity is not something that's given. Equilibrium means temporal stability of covariances and variances. So in other words, constant residual variances and constant residual covariances. So we have 2 covariances in this model. It's between the residuals of time 2 and time 3. So we can test whether those 2 covariances are remain the same over time, right? And then we can also go and do this for the residual variances. So between wave 2 and wave 3 for member 1, and wave 2 and wave 3 for member 2. So that's kind of something we may be interested in testing. So the stability influence model can be estimated by both structural equation modeling and multi-level modeling. So both have some advantages. So structural equation modeling has the advantage we can easily test submodels, right? Nested models, models that are simpler. So for example, a model that assumes stationarity or equilibrium. It's also very straightforward for testing whether distinguishable members, such as heterosexual couples, are empirically indistinguishable, right? And so this can be done for the variances and covariances and the direct effects. And you may do this separately then for the means and intercepts. So it's also very straightforward to estimate the model with 3 or more time points, right? So that's also a big advantage that structural equation modeling has. Multi-level modeling has also advantages, crystal clear. You know, it's more straightforward for indistinguishable members, such as homosexual couples, right? And it has also the advantage that a standard software package can be used, such as SPSS. So you can stand within a package, you know, right? The package you use for creating the variables, running the reliability analysis, etc. All right. So, but this model has also been criticized, or I mean, in general, these cross-lagged models have been criticized. They have been found that the effects are biased, right? Over or underestimation, so just a systematic bias. And that can be difficult to interpret. So the results may be not easy when it comes to the interpretation of them. So what's the solution? The solution is a random intercept cross-lag APIM. So this model can be estimated if there are 3 or more time points. If you have 2, no, that's not an option that we can consider. But with 3 or more time points, we can. And here is the model. So what you can see, it's very similar to the model we have seen before. What we now have is 2 random intercepts, right? We have a random intercept for member 2, and we have a random intercept for member 1. So this could be husband and wife. And the random intercepts are allowed to cover. What we then do is we estimate this stability and influence effect between the residuals, where we pulled out the effect of the residual, of this shared variance, the variance shared across time points within each type of member. So that's a very straightforward way to address some of the critique of the cross-lagged model. All right. So the next model I want to talk about is the dyadic graph curve model. So the dyadic graph curve model is probably one of the most prominent model in dyadic data analysis to test change, right? Or to analyze longitudinal processes. So and the model is shown here for 3 time points. And 3 time points, that's what we need, right? That's a requirement. So and you have here observed variable for member A. And here we have then an intercept and then slope for member A. And we have exactly the same for member B. So say husband and wife, right? So 3 observations, different time points, intercept and slope. And then, you know, this we have then also covariances and correlations. Some of them account for the non-independence. So, and some of them account for the association between the graph curve components within each member. So this model is a relatively straightforward extension of the graph curve model for individual data. So it estimates systematic growth for each type of dyad member. With 3 time points, we can estimate a linear change. With more time points, we can estimate more complex models. I will come back to this in a second. And it estimates correlation between the graph curve components, which also may be of interest. So in this model, change is modeled separately for each type of dyad member. So that is for distinguishable members. or distinguishable dyads, there is an intercept for member A and an intercept for member B, right? So there's one for the husband and one for the wife. And then, we have also a slope that we are estimating for member A and one for member B. So that's indicated here. And there are 6 covariances or correlations that we are estimating between the intercepts and the slopes. And each intercept and slope factor has a mean, and the mean is the fixed effect in the multi-level model approach, and the variance. And the variance is the random effect. So we have a mean for each of these latent factors, and we have a variance that we are estimating. So the graph curve model requires 3 or more time points. Now with 4 time points, a quadratic change or a piecewise growth can be estimated. And this is indicated here. So we have here the year of assessment, we have here the outcome variable, couples negative sentiment. And what you can see here, there's a decline in negative sentiment, and there was a substantial drop between 1991 and 1994. And this drop was modeled by introducing an additional intercept or level factor. So that's something that you can do when you have more than 3 time points. Now, graph curve models can also handle intervals that vary across time points. This is also reflected here in this figure, where you can see we have 14 years between time point 1 and 2, and then we have a 3-year interval for the remaining time. So this can be handled with this type of model. So that's a big advantage. So the dyadic graph curve model can be estimated by both multi-level modeling and structural equation modeling. And both have advantages and disadvantages. I will talk about those at the end of this presentation. Now, and no methodological presentation without an equation, right? So here we have an equation. So this is the equation for the dyadic graph curve model using multi-level modeling. So what you can see, we estimate an intercept and the slope for the males and the females separately. And then we have at level 2, we have our random effects that we are estimating. So you can use both for this type of model. Now the next model I would to briefly talk about is the latent change score model. So that's an interesting alternative to the graph curve model. It's similar to the dyadic graph curve model. It models change from one time point to the next time point. It provides an estimate of an initial score, I, and an average score, S, for each type of dyad member and correlation between those. So that's very similar to what we have seen when you say we have a trajectory and we have an intercept in the dyadic graph curve model. So it provides also an estimate of the proportional change beta for each type of dyad member. So this model is also known as the latent difference score model. And so here is the path diagram for this model. So we have, it's shown for 4 time points. So we have 4 time points here for member A. We have not the same time points for member B. And then we have a set of latent variables. So these are the error term or residuals. And then here what's interesting is this path labeled beta. So this is the proportional change. And then we have the initial score, which is similar to the intercept, and the average change score, which is similar to the trajectory that we have in the graph curve model. So that's the model. Now you can see it's a little bit a more complex setup. And of course, this requires the use of structural equation modeling. So it requires 3 or more time points. It cannot be done with 2 time points. So with 3 time points, this latent change score model for individual data, now for individual data, not dyadic data, is a saturated model. So a saturated model has 0 degrees of freedom. you cannot test whether the model is consistent with the data. It's because it's a saturated model. There's nothing good or bad about having a saturated model. What is known is that the graph curve model has 1 degree of freedom. So they are different, right? Also when it comes to the possibility of testing whether it's a good fitting model or not. Whether it's good to have that one has 1 degree of freedom and the other one has 0, it has both advantages and disadvantages. But what we can say, it's an interesting alternative to the graph curve model, and it may yield to significant results when the dyadic graph curve model does not. So it's, you may play around a little bit. So it assumes that the change between the time points is constant. So this constraint can be relaxed if there are more than 3 time points. So we have seen with the graph curve model, the time interval can vary across the observations, right? Here, it's less flexible, this approach, when it comes to time points that vary in the interval. Now, another alternative is the common fate graph model. So this model enables the analysis of change at the level of the dyads or the groups, right? So that's now a different logic than what we have seen in the previous model. All the previous models are kind of estimating the effects more on the individual level, right? On the level of the dyad members, husband and wife. Now this moves kind of everything up to a higher level, level 2. So level 3 with longitudinal data, where we have the relationship, the dyad or the group. So it can be used when the focal variable represents a shared variable. So what's a shared variable? For couples is the housing. The housing is something that people share will live in the same house, right? Or a dyad common construct, such as relationship harmony, relationship tension, maybe a relationship commitment, something that's where the people rate the same object, right? Both dyad members rate the same object, or the harmony in our relationship, for example. So it is appropriate if a researcher has a 3-level model in mind, right? Say on the bottom, we have observations, the time points. Then at the second level, we have the dyad members, such as, for example, my age, my wife's age, right? And then on the dyad, on the third level, we have variables for the relationship, such as family income or relationship duration, right? So this would be then the highest level. So it requires the use of structural equation modeling or multi-level modeling if you have indistinguishable dyad members. So, and here is the idea of the common fate concept that was introduced by David Kenny and his then doctoral student, Lavoie. And you can see here we have the variable marital harmony. So we have ratings for member A and member B. So that may be my rating and my wife's rating. And this serves then as indicator of the relationship harmony for a couple, right? And now we can extend this to a graph curve model. So we have a common fate variable for time point 1, we have one for time point 2, and one for time point 3. And with 3 time points, then you can see the structural part of this model is exactly the same as we would have for individual data and the graph curve process with a level or intercept. I use them interchangeably and a slope component with the linear trajectory. What you also have is residual correlation, which reflect kind of the non-independence that we have here in this data over time, the non-independence over time. So this model models change at the group level, relationship level. When we're estimating a linear trend, there's one intercept and one slope factor. Now you can see this model is simpler than the dyadic graph curve model when it comes to the structural part, because there's only one component for each intercept and slope. This model is then particularly attractive for the study of complex mechanisms because it's simpler. And a complex mechanism is something I consider mediation, right? I mean, mediation with dyadic data can get very messy, and we have many paths, and it's difficult. It's not difficult to estimate a complex model. Everyone can do this, right? But the challenge is describing the results, looking for patterns. So that's the biggest challenge that we usually face when we have a complex model. So, but going with this model, or at least part of the variables, modeling as a common fate approach, that can be very helpful, simplifying the results. Another thing is latent class analysis. This is also, if you have a large sample size, you may want to look for latent subpopulation that's different in the effects. So that's also something that you may want to consider using this model if the variable represents a shared variable or a dyad or a relationship variable. So the common fate models are prone to estimation problems. Everyone who uses that model has probably run into estimation problems such as non-convergence. That's the worst case, or a matrix that is not positive definite, right? Or Haywood cases. I mean, usually matrices that are not positive definite, maybe you don't get all the results you want, right? For example, standard errors. Haywood cases means you have a negative variance somewhere, right? And if you have a negative variance, usually you have also a standardized estimate that's out of range. For example, a correlation that's larger than 1, right? So this is a problem of this model. Now, the last model I'm tackling on this morning is the LAPIN. So it's a longitudinal version of the actor-partner interdependence model. It's a natural extension of the cross-sectional APIN, and this model can be estimated using structure equation modeling, as kind of done in the paper of Gistlink and Tom Lois. Okay, they also contrast their results with using multi-level modeling in SAS, and there's also a paper where authors talk about that approach. Now, the model is shown here for, say, 3 time points, and so we have time point 1, 2, and 3. And now, what's different here in this model than in the previous models, now we have 2 variables. We have, for example, stress, as we have a predictor, and we have an outcome, stress and harmony, right? And so this is kind of a cross-sectional model. Stress and harmony at time point 3, the same at time point 2 and at time point 1. And what we have here is correlations among the residuals, accounting for the non-independence. And they also introduce random intercepts for the outcomes for, say, husband and wives. And the intercepts, these random intercepts, are allowed to correlate. Now, when setting up the model this way, we can ask different questions. For example, how does one's own stress affect one's own harmony? So this is kind of the actor effect we may be interested in. How does the partner stress affect one's own harmony? I mean, we must be careful with using the term effect, crystal clear, because it's a cross-sectional approach that we are kind of using. But it's a little bit simpler for me to use that term than other terms. So but just be careful using those. And another question would be, how does one's own stress on a particular time point affect one's own harmony as compared to one's own average stress, right? So how does the partner stress on a particular time point affect one's own harmony? So that's the partner effect. And then you can also kind of address the question, what extent does the time averaged harmony vary between the partners? So these are the correlation. This is the correlation between the random intercepts. So there are many questions that can be asked. And you can also test, for example, do effects get stronger over time? Do effects get weaker over time? For example, if you study couples, going through a separation, divorce, may the effects get weaker, may also get stronger, depending on the variable. I mean, these are interesting questions. All right. Now I want to talk a little bit about advantages and not just the advantages that each method has. So structural equation modeling has advantages. There is an absolute fit, right? Maybe you want to argue with me. No, I think I'm happy if I don't have to deal with fit, right? I'm fine with that position. And sometimes I also say, let's switch to multi-level modeling. We don't have to deal with a bad fitting model. And so, but I think, from a perspective of, I want to find a good model. I think having an absolute measure for the fit is a good thing, because you may think about how you could improve your model so that the model fits your data, is more consistent with the data. So we have more options for specification and respecification of model and testing specific submodels. So patterns, we did a paper on patterns in the APIM. You can test those patterns in a very straightforward way using structural equation modeling. So more flexibility in the error variance structure. When you use multi-level modeling, you need to consider the variance covariance structure, and you are limited to kind of options that the software has. So it allows for latent covariates. If you want to control for covariates, allows missing data in level 2 variables. For example, allows for missing data in income, family income, relationship duration, without having the complications eliminated from the analysis. So it allows the prediction of a level 2 outcome variable. So a variable that's not time variant, a variable that's time invariant, which is also a big advantage. For example, say you want to predict number of children a couple has, or something like that, a level 2 outcome. So it's a little bit hard to think about a level 2 outcome if it's not depression or developing a depression or something like that. So analysis of multiple groups. So that's very important, especially if you have, if you study couples and you have heterosexual and homosexual couples. You have 3 types of couples, right? You have gay, lesbian, and heterosexual couples. I think that's structural equation model is an excellent approach for analyzing this type of data. Latent class analysis, I mentioned this, also a big advantage that structural equation modeling has. Then multi-level modeling has also advantages. So it's much better with time unstructured data. So different intervals for participants. So if I may have a different interval than my wife, and multi-level modeling can handle this. And we may have a different interval when we return our surveys than another couple, right? Multi-level modeling can handle this. In structural equation modeling, you are limited in handling this. You introduce more missing data by using different approaches. So it's better with many measurement occasions. So many time points. If you have a dozen time points, probably it's better to go with this approach. Yeah, also because of the issue with model fit, right? It's very likely you will not find a good fitting model if you have many time points. Daily diary data, for example, or studies can be very hard to fit with structural equation modeling. So it's easier with time varying covariate. So if you have income and you want to control for income, and income can vary across years, much easier than having such a covariate in a graph curve model process with structural equation model. Better for smaller samples. If you have sample sizes, say below 100, go with multi-level modeling. And structure equation modeling and multi-level modeling produce identical point estimates if maximum likelihood estimation method is used and no missing data and the data are normally distributed, then they are the same, right? Standard errors can differ, but asymptotically, the results are identical. In those models, you have the option to choose one of them because both can be used. All right. That's from my side. Thank you very much for your attention. Thank you again for your interest.
Thank you very much, Dr. Lederman, for the wonderful lecture, and thank you for understanding while we are trying to figure out our technical issues. Next, our second panelist is Dr. Karen Lyons, and Dr. Lyons is a professor at Cornell School of Nursing at Boston College, and she will give us a talk on using longitudinal dyadic data to study midlife and later life couples. So please welcome Dr. Lyons.
Thank you very much. I'm thrilled to be here and to be part of this panel with Tom and Rob. And actually, that was a fantastic presentation and gives you the reason why most of my work has been in dyadic growth curve analysis and mostly with an MLM approach. So you'll have to keep that in the back of your mind as we go through this. So I was asked to talk about opportunities and challenges of doing this type of work for mid to late life couples. And so I'm going to share more of the kind of examples of the type of research we do in mid to late life couples. And I'm going to go through this, give you some of my examples and then also some other published work. And if you have the slides, you'll have all the citations in there. Okay, so what are the kind of reasons why? Tom talked about this a little bit. I'm going to talk about it too, because I think it's really important when you step back and think, well, I have longitudinal data. What will I do with it rather than just running a longitudinal model? So again, I think this has been said really well. It's about understanding a concept over time that's co-varying within a relationship, whatever that relationship might be, and whether people are married or not, whether they're same sex or heterosex. The other thing is that you're understanding a dyadic concept as it moves over time. So we have both of those examples that we've just talked about, where we might have the health of both members of the couple co-varying over time. We might also have one of those common fate types of models, like harmony that's moving over time, or I've done a lot of work around incongruence as a dyadic concept over time. So people often talk about similarity, synchrony, discrepancy, incongruence. A lot of those words tend to be tied to the model that you use to estimate whether or not it's something that's more correlational versus gaps and differences. But we'll talk a little bit more about that. The other thing is when you look at trajectories over time in couples, oftentimes we're trying to get to intervention or figuring out how to support couples. And so sometimes we're backing up into those baseline risk factors to see, well, can we see anything in the initial stages that would actually give us a sense of who's going to change faster over time, which couples are going to be more at risk over time. So a lot of the work that I do often tends to focus in on when one person in the relationship has a chronic illness. So we're often trying to see if we look at them. And one time we did a study where we had 10 years of data to be able to look at what was changing over time and came back to baseline to find out what can we tell at baseline that's going to tell us who's going to decline faster in health, who's going to have faster increases in their depression over 10 years. The other thing that's really interesting is thinking about those time varying covariates. And that's something that I've done a lot of work on and find it very interesting to kind of tease out, not just controlling for a change in a variable, but can we actually think about change in different ways? And I'll give you some examples of that. And I think patterns and subgroups, I think that's a really big emerging area in older couple research. We're seeing a lot more of it, and I'm excited about what we might learn from that. And then you can't really talk about interventions without talking about longitudinal data. And I think the other thing that we're seeing a lot more work and thought about is taking all of these approaches and models that Tom talked about and thinking about how can we actually evaluate couple-based interventions differently than we do and how we all learned how to do it for individuals. How can we tease apart the individual benefits of an intervention from the couple level benefits of an intervention and find those couples who are either benefiting the most or who are actually at risk. And so really kind of getting up into the dyad level. So if you haven't read this paper, I highly recommend that you read this. This came out in 2021. And while there are lots of dyadic theories and frameworks, and obviously the caveat ticker tape here is I co-developed a theory too, but this one is a really interesting, important one to really read and think about if you've got longitudinal data, because it's looking at couple synchrony and health over the adult lifespan. And what they've done is they've kind of used a lot of what we know, what research has been done. They're primarily looking at health and physiological health, but they're trying to kind of like almost push us out there and provoke us to think about, are they right or wrong? They're talking about times in the lifespan when you would expect higher levels of synchrony and health in a couple versus lower levels. And I think this is going to really push us all to start thinking about, when is it beneficial to be in synchrony, when is it not, and are they right? So I always love papers that provoke us to do more. So let me just give you a couple of actual published examples of the types of things that Tom was talking about too. So this is dyadic growth curve modeling, and this particular publication is looking at older dyads where one person had a stroke. So we caught them right after stroke. They were in rehab for 12 months, measured every 3 months. And what's happening is we're trying to actually get them back to function, right? So they're in rehabilitation and getting measured every 3 months. So we're looking at their physical and mental quality of life over those 2 time points and seeing those trajectories. So these are the 2 average trajectories, and no surprise, the person who had the stroke has poor physical and mental quality of life over time, but you can see mental quality of life, the gap isn't quite as far away, and you can see that actually they're getting a little bit closer. We have variability around these trajectories that we're often mostly interested in predicting, and then we put our baseline predictors in there to see if that predicts it, and then some time varying covariates. Here's an example of kind of the same thing in lung cancer, right? And lung cancer, the average or median age is 70 years of age, right? And what you see here that's interesting is, once again, person with lung cancer at diagnosis, and then we measure them every 3 months for 12 months, has poor physical quality of life, no surprise. But if you look over your mental quality of life, it's very different from stroke. And one of the things that I have learned from being in multiple different chronic illnesses as a gerontologist is that they're not all the same. And I'm always interested in what's similar and what's different in each illness context. So lung cancer is the leading cause of death in cancer right now. More people die of lung cancer than any other cancer. So there is a huge amount of uncertainty. We have new treatments, but nobody knows how they work or the long-term effects. So this is a very scary illness for people to encounter, whether it's themselves or their partner. So this is not surprising that care partners and spouses actually have poor mental quality of life. I love this quote. I mean, I came out of a HDFS program and I'm a gerontologist, so I love the idea of change and stability and getting into that. This quote really kind of gives you that sense of, and if you can't see that at the back, it says, then there's the man who drowned crossing a stream with an average depth of 6 inches, right? And this is why we love these types of models where we're looking at an average, but then we're also looking at the variability around the average. So in this next slide, we take 25 random couples and show their depressive symptoms around that average. You know, in the very, very old days when I started out and people were very new to MLM and even SEM for some of this work, you'd always have somebody in the audience going, well, how come you're moving away from repeated measures ANOVA? And how can you be looking at all that stuff? Because that's error. And now we know it's not error around an average, it's actually where all the magic is happening. And we're trying to find the couples who are at highest risk or the couples who are actually doing really well. So let me talk a little bit about time varying covariates then, because Tom introduced this, and this is something that's always intrigued me. So sometimes you'll look at time varying covariates as something you want to control for, and I think you give the example of income, which is a really good one, right? The other thing is sometimes people look at seasons. So if you have a phenomenon that changes by season or time of year, something else, that when you're looking at your phenomenon. One of the things for me, though, is I'm really interested in the different types of change. So we can actually decompose the change that's happening in that time varying predictor into, let's say, for instance, we have depressive symptoms, and we've measured that over 12 months in our couples. And we think that maybe the symptoms of the illness, let's say lung cancer, is associated with that change in depressive symptoms. But we're not sure, does it matter change over 12 months or change every 3 months? And what we're able to do is actually model both at the same time and see which one is accounting for more variance in depressive symptoms. So we're able to tease apart an aggregate change that happens over an interval of 12, 24 months, and then the fluctuating time varying piece of that every 3 months. So here's an example that we did back in those depressive symptoms in lung cancer couples. And what we were looking at was every 3 months, we asked about the patient's pain severity and their physical function. And in the first year of lung cancer, for those of you who don't know, we usually have very, very few people with advanced disease who are alive at the end of 12 months. So you have, depending on your stage of illness, a lot of mortality and a lot of fear, even if you're actually treated, that your cancer will come back. So it's a very scary time. And what we were trying to do was look at whether or not people were making decisions and preparing for bereavement. So what we found was that when you look at the aggregate change in physical function for the person with lung cancer, or that actually impacted the depressive symptoms for both. When you looked at the average change in pain severity, so over the 12 months, if the pain was up or down, that also significantly predicted depressive symptoms. When we looked at the changes that were happening every 3 months, only changes in physical function had a time varying effect on depressive symptoms for both. And only changes every 3 months for pain were associated with the person who had the lung cancer's depressive symptoms. And what we found is this pattern in a couple of places, which now drives the interventions we do, because pain is really hard to see. Function is a lot easier to see. So if you're in a relationship with somebody and they have an illness, or even maybe if they don't, you can see changes to their physical function faster than you can see their pain, faster than you can see even their shortness of breath, faster than you can see their fatigue. So what we tend to do now is coach partners into, if you're noticing a change in physical function, reflect and prompt the person, are they having more pain today? Are they actually feeling more fatigued because they're lifting less, they're not walking up the stairs as much? And so that's one way, even with couples who maybe don't have a diagnosed chronic illness, that they can actually tune into one another in terms of what's the physical function change, actually kind of like almost an early indicator of some of these symptoms. And then we did the same thing here in the stroke couples, where we were looking at, again, when they were in rehab over that first year, was there more of an impact when they had declines or improvements in physical function? And yes, the time varying effect of physical function change every 3 months accounted for more of the variance in quality of life than the aggregate change over time. The other reason I just find this personally interesting is because it gives me a sense of what do you actually have to ask every 3 months, right? And when we're thinking about response burden in older couples, that's important. So this kind of a model gives you a sense if something isn't changing that much, it's not having a time varying effect in the same way, then it can just be that time varying traditional, like you would put into an SEM model of just controlling for it as opposed to looking at it over every 3 months. Then the next thing that I think is really interesting, and also Tom talked about too, are these dyadic second order variables. And I use that term only because I've been influenced by Thompson and Walker's paper in 1982, and that's how they talked about these second order variables, where you take 2 pieces of information, one from each member of the couple, and create something new. So you can create like an average score, right? Or you can create a similarity synchrony score, you can create an incongruence and difference score. And I've done most of this work in symptoms because I'm often looking at whether or not they're on the same page in terms of symptoms, because that drives behavior, it drives decision making about how to actually manage those symptoms as a team and a couple. So for people who are not familiar with this, if you had no incongruence with your partner about their symptoms, so you're in complete agreement, you'd be this red dashed line, right? So 0 means no difference between them. And then above the line, those are the scores that when the patient is saying that they have more dyspnea, more shortness of breath, or sorry, lower shortness of breath, and then below the line, then it's the opposite. And the reason that I show this picture is because sometimes when people do this, even outside of just multi-level modeling and SEM, people will get into incongruence research and just do different scores. Or even when you're in an MLM, you'll get an average that's often very close to 0, because there's 2 types of incongruence happening and they often cancel each other out. So you know, I've done this for 20 years. I'd say the first 10 years of doing incongruence research with this kind of symptom incongruence, people just have done a whole bunch where they've kind of concluded there's nothing going on here. People are on the same page about symptoms. Most of the time, that's because they were not using methods that were showing us the variability around the average. So just a couple more pictures. This is pain severity over time, and then physical function. Great. And then I often get, especially from clinicians, when I present, I'll often get asked, well, what does it matter if they're on the same page? And the reason that it matters if a couple is on the same page about their health, about their symptoms, about what's going on, their self-management strategies, is because it drives their behaviors. It drives the decisions they make. It helps them to make better shared decision-making, especially about that chronic illness. And so we kind of put it all together in this paper where we actually looked at how symptom incongruence around is changing every 3 months over time for physical and mental quality of life in these couples. And what we found is that the changes, the time varying changes over that first year of lung cancer were significantly accounting for changes in physical quality of life, not just for the person with lung cancer, but for their partner as well. And people don't often think about that when they're focusing in on one member of a couple. They're always focusing in on, well, you've got the illness and I'm your supporter. And we've got to kind of move a little bit away from that and think of this in a more balanced place. And what's interesting is that when we looked at mental quality of life, and we talk about that in the paper, it wasn't the gap between them or how far away they were in terms of symptoms, it was directionality. It was who was saying there was more pain or less pain over time. So that's an interesting place to kind of explore further. So a couple of other publications that might be of interest and kind of get you thinking about ideas for your data. I love Courtney Polonick's. That was one of my favorite articles of 2021. So she used the health retirement study to look at mid to late life couples in terms of whether or not they had congruent or concordant chronic conditions or not. So we know that the older you live, the more likely you're going to have one and more chronic conditions, right? So what they did in that paper was they said, there are self-management strategies for chronic illnesses, right? You might have heart failure and you have to watch your sodium. You might have diabetes, you're watching your glucose. There are others where you might have to do physical activity. There are others where you're actually watching your diet. And so what they did was they said, does it matter if you're managing more than one illness with different self-management strategies, either as a person or as a couple? So they had couples where they had concordant conditions and discordant conditions, and people within them had concordant or discordant. And what they found predicting depressive symptoms over time was that it matters for the men in the relationship, not for the women. So men were more impacted by having this kind of discordant chronic condition in the relationship than women were, which I think is just the tip of the iceberg. Lindsay Miller did something very similar, but with cross-sectional data, where she was looking at incongruence in physical health status. So not necessarily a chronic illness, but just within that relationship and couple when they are in older adulthood. If they have some kind of difference in physical health status, does it associate with depressive symptoms? And it does for men again, but not for women. And in that paper in particular, they also found that it was more likely that it was the woman in the relationship who had the poorer physical status that was associated with men having higher depressive symptoms. I would love to see more of this work. I think we're just getting going in what that means in terms of as we age in a relationship, those very first little triggers of our health is changing. Maybe it's changing for one of us faster than another. And what does that do? Does it actually help us to understand why people maybe pull back, right? Does it matter which member of the relationship gets early signs of cognitive impairment or physical decline, and then suddenly we're not socially engaging? So I think there's a lot more work there. And I love the work that's coming out around personality in older couples. And I know a lot of work is done on dyads in younger parts of the lifespan, but I'm focusing mostly on what we know around older couples. That paper is really great in looking at concordance and discordance in personality within older couples. And then they also associate it with perceived spousal support over time. And there's a gender effect in there too. And then this is a really great paper by Holly Laws and her colleagues where they looked at convergence changing over time. And they looked at newlywed couples. You could easily think of a question in older couples where you might think about whether or not we're getting similar over time or different. And Tom gave great examples of that, you know, maybe divorce or something else, some life event where you might actually wonder whether or not we're converging more over time. And then lastly on this topic is the work that Stephanie Wilson did very recently, which is really interesting, looking at cardiometabolic risk factors in older couples. They looked at concordance and whether it's changing over time too, in like glucose and physical activity. And what I like about this is it wasn't just that we're doing the same shared behaviors that is associated with this cardiometabolic risk in couples, but also the closeness. So like sometimes we get too focused in on just the physiological stuff, but there's a lot to this. It's very nuanced in terms of what might drive our cardiometabolic risk as couples. And then this one I love. I am not an intensive longitudinal person. I love the work and I would like to get to do more of it, but I love this paper. This is a very recent paper that will give you that lifespan perspective. So they have a combination in here of intensive methods and looking very far over time and gathering the data in a whole bunch of ways. And what they pretty much were looking at was positive resonance and a conflict interaction. And the higher the positive resonance after a conflict, the more they were able to predict health 13 years later and longevity 30 years later. So if we're really going to start thinking about older couples, it's going to be important to also backtrack into what happened to them before they became older couples. Okay, Tom talked a lot about this in terms of patterns. I'm also fascinated by patterns. Here are 3 examples of cross-sectional papers that have been done on mid to late life couples around patterns in dementia dyads, where they're looking at the involvement of the person with dementia. And then we have this another great one here on personality and profiles of personality in couples. And then this one down here that Josh Novak, they just published, which I love, because not only are we looking at profiles of health in couples, but they took this really broad perspective of health. So they have these profiles of physical health, mental health, emotional and relational health. And I think the more we can understand where are the couples that are at risk and where are the couples that are actually experiencing optimal health, I think that's going to help. And if we can move a lot of this over time, I think it will really help us to understand where we need to intervene. We've done a little bit of work ourselves on this. So we actually combined multi-level modeling and latent growth mixture modeling to actually find patterns of mental health and lung cancer, and found 3 different trajectories. The congruent group, who had pretty much almost identical mental health over the 12 months, the middle group, which were disparate, and then this last group, which were more parallel, improving. And the reason, and we actually associated the characteristics of baseline that were actually explaining some of this. And it's not the illness characteristics, it's the interpersonal and family support characteristics. But the reason I share this slide with people a lot is because congruence is sometimes a good thing and sometimes not a good thing. So when you look at something in terms of symptom congruence, you want people on the same page because it helps them to actually make tough decisions together. It helps drive their behaviors. But when you're talking about health, congruent health isn't always a good thing. So if you look at the bottom 3 panels, the one on the left-hand side, they have congruent physical health, but it's not good, it's awful. So we have to kind of tease out congruent as sometimes good and sometimes not good and figure out when does it matter. But when it's something like health, being on the same page isn't always positive. So challenges then. This is an interesting one for me because sometimes I'm an optimist. So when I think of challenge, I think, well, that's just the next great opportunity. Somebody's going to fix that or figure it out, right? And that's what we're actually going to push out and do something new. When I was thinking about this, it was hard to tease out challenges for dyadic longitudinal from just what we know about challenges of longitudinal in terms of all the logistics and problems that will come up. I think obviously the biggest one that's not up here is just getting the dyadic longitudinal data. It's hard enough to get cross-sectional, but longitudinal is really tough. So I totally appreciate how hard it's been to probably get the data you have. I think one thing that's not talked enough about, at least when we publish, is where do we set time? Where's initial status? You know, it's kind of like everybody does it a baseline, but sometimes that doesn't make any sense. So it's like just even reflecting on where do you want to center time? Where do you want time to begin? Really easy when it's, let's say, a diagnosis in a really definable illness, like maybe cancer. Really easy when maybe it's a stroke. When did the stroke happen? Really hard when it's something like dementia. Where's the beginning of that? Even heart failure, where's the beginning? Is it the first heart attack? Is it the first time you go to the hospital? When we don't have illness, let's say it's just, you know, we're looking at couples who are not chronically ill, who are just, when do they come in? Is it by age? Everybody at 50, so that's the start of time. So it's really thinking about whether or not you're putting people in and then starting to look at baseline or intercept or initial status in a way that might not make sense across all of your couples. And I've actually done studies where I've centered time, and I'm sure that Rob and Tom have too, centering time somewhere else. Sometimes it's a final status. Sometimes I'm just looking at, you know, in the middle. So just allowing yourself, maybe free yourself up a little bit sometimes to think about that. The other one I will say is people who know me know that I love theory. So I think I'm more of a conceptual methodologist, but I can't do that without theory. So I think the only way that we're going to advance the field of dyadic science and dyadic health research around older couples is if we test theories and push them out and really make contributions to what the gaps are in our knowledge. Okay, and then I'm going to finish up here with kind of what I think might be some of the emerging and future directions in this area. I think there's got to be a lot more work done on the concept of dyadic health. And I think, you know, we've tried to do a little bit of that work. That's in part of the theory that we developed in terms of balancing the health within a couple, even when one of them has a chronic illness. So there just isn't enough attention. It's usually like, well, you're the person with the illness and you're the care partner. And we do that a lot in older adulthood, as opposed to this is still a relationship that has longevity and has gone through phases. And maybe that's not the way the couple is viewing it. So how we help them to balance the health and how we learn how to do that as methodologists, I think is going to be important. Patterns over time, then we've talked a little bit about. I think it's going to be really interesting to think about this impact of initial change in the couple as they age. You know, changes that might not be even obvious to them. There are a lot of people now, and I know Lindsay Minner just got an R01 that she's about to start to try to pick up these very subtle changes in health in older couples. And then how are we actually going to be able to backtrack to be able to see that and head it off before even the couple might? I think the research we've seen around whether one person is changing before the other and who is it in the relationship is going to have an impact on maybe how they interact and how socially engaged they might be. I think the idea of synchrony and incongruence is fascinating, and we need more of that. I mean, that's somewhere I think we're going to really grow and push things out a little bit. And when does it matter when we're on the same page and when does it not? When is it important not to be the same? And I don't think we yet know that. And I think there are really great methods that are used there. So there's a vast spectrum of methods that are used to get at this idea of synchrony and incongruence. And I know Bill Chopik is at the back of the room, and I've already met you on Zoom, so I'm very happy to be in the same room with you, and has done great work in using response surface analysis around some of these ideas. So there's lots of great things that are going to happen, I think. Anything that gets us beyond an average, I'm all in favor of, because there is no average couple. No average couple shows up in our interventions or at the doctor's office. And so the more we can do something that's not one size fits all, the better. Diversity, I think, is the big elephant in the room with dyadic research. I think this group is probably leading us in not having homogeneous groups of dyads. But if you look at the vast amount of dyadic research in the world, it is primarily homogeneous heterosexual couples that are white, and all of our theories are based on that data. So I put myself in that box. We have to do a much, much better job of understanding how these phenomena play out in diverse samples. I also think the other exciting place here is life histories. Like, what do people bring to the table when they enter older adulthood as a couple? They've had vast amounts of time as individuals and in that relationship before they get here. Jackie Smith talked about this. So the HRS has the life history interview in there. So there's going to be some ways to look at this. I think that's why you see more personality dyadic research coming out. It's why people are going back to attachment theory. I've even seen people start to bring up adverse childhood events in old age when you're in a relationship, in terms of what are the impacts of all of this as we grow older and what do they bring to the table. And then lastly, I think we'll see more of this physiological and trying to get at people's illness as we grow older. We have more older couples to take care of, more nuanced approaches to change. And then this last one here that I will leave you with, I also really love. I think it's a really new and exciting way of doing unobtrusive monitoring. So they come up with this new technology called the Diamond, which is when two people come together who are wearing smartwatches or have smartphones, it automatically starts recording. So you don't have to program this. It's just literally we're going to get natural conversations of when those two people are actually within a certain proximity to one another. Lots of ethical questions there, obviously. But I think it's going to be a game changer in the way that we might be able to capture the real conversations that are happening and interactions between couples. So hopefully some of that got juices flowing and provoked you to think about some questions, because I think this is a very exciting area of research.
Thank you so much, Dr. Lyons, for such an insightful presentation. Now, next, we have our third panelist, is Dr. Robert Ackerman. And Dr. Ackerman is an associate professor in the Department of Psychology at the University of Texas at Dallas. And he'll give us his talk on practical applications of longitudinal dyadic analysis. So please welcome Dr. Ackerman.
Yeah, thank you so much for inviting me. I'm really excited to be here. So for this talk, what I wanted to focus on are the kinds of analyses that we can perform when we have 2 waves of data, as well as when we have 3 waves of data. So I really wanted to make it specific to what's possible with the data that you all have collected. So for my talk today, I'm first going to go over the longitudinal actor-partner model analyses when you have distinguishable dyads and 2 waves of data. Right, so the examples I'm going to give are the cross-lag APIM model with 2 waves of data, as well as the overtime actor-partner models with 2 waves of data. After that, I'm going to talk about one of the interesting opportunities you have since you have gay, lesbian, and mixed gender couples, right? So I'll talk about the possibility of using gender as a mixed variable, right? Which will allow us to be able to see whether or not different kinds of effects depend upon whether somebody's in a gay, lesbian, or mixed gender relationship. Oh, not yet. Sorry about that.
Okay.
And then I'll talk about longitudinal actor-partner model analyses that are possible when you have 3 waves. In particular, I'll talk about the possibility of a latent decomposition of time-varying predictors into between-person and within-person effects. Then I'll talk about how that application can be used for the cross-lagged actor-partner model with 3 waves, as well as the overtime actor-partner model with 3 waves. And then I'll talk about the dietic growth curve model briefly, and then just have concluding comments on just performing dietic overtime analyses in general. All right, so this is going to be the cross-lagged actor-partner model with 2 waves for distinguishable dyads. So as we can see here, both dyad members' outcomes at a given time point are regressed on their same variables at the preceding time point, both them and their partners, right? So the cross-lagged actor-partner model enables us to look at both stability and influence for some given variable of interest. So importantly, because we only have 2 waves, it's not possible to disambiguate between and within person effects, right? So we have to be careful about how we interpret stability in this situation. So for all intents and purposes, the way that we can interpret stability here is the stability of rank order individual differences from one time point to the next. So basically, if you have a coefficient that's equal to 0, it means that people completely reshuffle their positions relative to one another, right? Whereas if you have a coefficient that's stronger and positive, it means that people are generally maintaining their rank order over time. Now, the influence coefficient here, and again, I'm using influence informally, right? I don't want you to think that we're invoking causality here, right? But because we're controlling for the person's outcome score at the previous time point, this partner effect is going to enable us to look at how the partner's previous standing on the variable at the previous time point is related to residualized change in the outcome at the current time point, right? So we're able to look at this influence over time in predicting residualized change. All right, by the way, I'm just focusing on the focal parameters of interest, right? So yeah, I'm not focusing on everything. All right, so now what I'm going to do is I'm going to show you the overtime actor partner model with two waves of data. So as we can see here, we're predicting both diet members' outcome scores on a given variable y at time t, right, as a function of their scores on x at the preceding time point. And importantly with this model, we're also controlling for the person's level of the outcome variable y at the preceding time point as well. Right, that's going to be important because it's going to have implications for how we can interpret the resulting actor and partner effects. And so here, we're going to interpret the actor effect as the prospective effect of the participant's x variable at the preceding time point on the residualized change in their outcome variable at the next time point, right? So as an example, maybe I'm interested in looking at the relationship between conscientiousness and some form of health-promoting behavior. It might be the case that if I happen to be higher in conscientiousness at the preceding time point, right, this is going to be related to some form of residualized change in my health promoting behaviors at the next time point. The partner effect is looking at the relationship between the partner standing on X at the preceding time point and the person's own residualized change in Y at the current time point. And so again, if we're looking at conscientiousness and health promoting behaviors, it might be the case that if you're in a relationship with a partner that's super conscientious, right, they're going to be going to the gym, going on walks, right, cooking really healthy food, right, and you're going to be benefiting from this over time. So it might be the case that your partner's level of conscientiousness at the preceding time point is related to you also engaging in more health promoting behaviors. All right. Now what I'm going to do is I'm going to talk about the possibility of treating gender as a mixed variable, right? And I'm going to be using an effect coding approach to gender, and it's going to seem a little bit complicated. So basically what I'm going to do is I'm first going to show you the kinds of effects that you can estimate with model. And then I'm going to show you how to specify the model as well as how to interpret the effects afterward. So it's going to seem complicated, but I'll go through how to interpret each of the effects. So the first thing is that when you have a mix of gay, lesbian, and mixed gender relationships, right, you can treat gender as something called a mixed variable. It basically means that gender varies both within couples as well as the average varying between couples, right? So we're able to actually look at both actor and partner effects, right? So an actor effect of gender here, right, would be basically asking whether or not there's mean level differences in the outcome as a function of the participant's own gender. So if I'm going to take disclosure for an example, right, and we're assuming that gender is binary for the present example, right, we would be basically asking, do women disclose more on average compared to men, right? Now the partner effect is asking whether or not there's any mean level differences in the outcome as a function of the participant's partner's gender, right? So an example of this applied to disclosure would be, do people tend to disclose more when they have female partners versus male partners, right? Oh, not quite yet, sorry. And then the actor-partner interaction is where you really get to see whether or not there are differences as a function of people being in gay, lesbian, or mixed gender relationships, right? And so here we would be able to ask, does the effect of my gender on my level of disclosure depend upon my partner's gender, right? Now, importantly, through all of these examples, we're just looking at mean level differences, right? So this is relatively straightforward for the time being. However, we can also apply the same logic to looking at whether or not different kinds of effects from other models, such as stability and influence, also depend upon the gender composition of the couple. Now here's where things are going to seem complicated, but again, I'm going to go through and then I'll come back. So as an example, let's consider whether or not the stability and influence of disclosure within a relationship depends upon whether people are in gay, lesbian, or mixed gender relationships, right? So here we have the stability and influence parameters, right? So disclosure from both partners at the preceding time point, predicting disclosure currently. So the first thing we do is we would add both dyad members' genders into the model, and we would impose equality constraints on the corresponding actor and partner effects. I probably should have chose better colors, but the same colors are equal, right? So we're imposing equality constraints on the effect of the partner's gender and the person's gender on the relevant variables there. We also include the interaction term between both partners' gender, both participants' gender variables. Then we include a two-way interaction between the participant's gender and their disclosure at the previous time point, and impose appropriate equality constraints for the actor and partner effects. Then we include another two-way interaction between participants' partner's gender and participants' disclosure at time t-1, and impose equality constraints on the actor and partner effects. Then finally, we have the three-way interaction, right? The reason we're building it up this way is that in order for the three-way interaction to mean what it means, you have to have all the lower order interactions and first order effects. So here, the interaction is between both partners' genders and the person's disclosure at the previous time point. Now, let's say that we grand mean centered the disclosure variable at the preceding time point, and we also affect hooded gender such that -1 are women and 1 are men. By the way, again, I'm assuming that gender is binary here. You don't have to actually assume that, but the model would become much more complicated if you don't. All right. So the first thing is that the actor effect for this three-way interaction term is asking whether or not the degree of stability depends upon whether people are in gay, lesbian, or mixed gender relationships, right? So you might be curious whether or not the stability of disclosure that we witness in a particular sample, right, is different for these different kinds of couples. The partner effect for this three-way interaction is looking at whether or not the degree of influence, right, depends upon the gender composition of the couple. Right? Then this two-way interaction between the participant's gender and their own disclosure at the previous time point is asking, does the degree of stability depend upon the person's gender? So, are men more stable than women? The partner effect would be asking whether or not the degree of the participant's partner's influence depends upon the partner's gender. This effect, this two-way interaction, is asking whether or not the degree of participant stability depends upon their partner's gender, right? So the previous one was looking at whether or not it depends on the person's gender. And the partner effect here is looking at whether or not the degree of participant's partner's influence depends upon the participant's gender. Then the interaction term between both is just looking at whether or not the effect of the participant's gender on their level of disclosure depends upon their partner's gender. The after effect is asking whether or not participants' level of disclosure depends upon whether they're a man or a woman. And the partner effect of disclosure is just asking whether or not people disclose more towards women versus men. So yeah, it seems super complicated. I actually came up with different handouts for the workshop portion that actually illustrate how to do all of this. So it seems complicated, but it's just breaking stuff down. All right, so now I'm going to go over the possibilities of 3 waves of data when you have longitudinal dyadic data. And so this is something that Tom had mentioned in his talk, but a big criticism that's leveled at the cross-lag panel model is that it confounds these autoregressive and cross-lag effects with stable between-person variance, right? And so basically the issue is that whenever you have a variable that varies over time, right, it has both between and within person effects. And so it could be that, when you're looking at self-esteem over time, right, that the average level of self-esteem, right, is going to differ between participants. But it could also be that when you look at self-esteem over time, the person's own level of self-esteem is also going to fluctuate around their baseline, right? And unless we disambiguate those two sources of effects, right, it's difficult to have a very clear interpretation of any resulting coefficients. And so to remedy this, right, we can actually use a variant of the random intercept cross-like panel model and apply it to the cross-like actor-partner model, otherwise known as the stability influence model. And so this would be what the random intercept cross-like actor-partner model looks like. And so basically, we have women's outcome scores across 3 time points. We have men's outcome scores across 3 time points, right? And the random intercept is basically getting at that stable between person variance over time, right? And so the covariance here would basically be asking whether or not men's and women's average levels of Y are correlated, right? But then we also have the within person portion of the variance that's also disentangled here. And importantly, when we're using the random intercept cross-like actor-partner model, right, the stability and influence coefficients have to do with the within person portions of the model. So, yes. So this has implications for how we actually interpret the coefficients, right? So because these are regressions that are based on the within person effects, we actually interpret stability now as the degree of carryover or inertia of a variable over time. Because basically, we're looking at how a 1 unit increase in the person's variable at the preceding time point relative to their baseline is related to their score on the outcome at the current time point relative to their baseline. And so think of it like this. If you have a larger coefficient here, it basically means that if somebody scores high on their outcome variable at the preceding time point, right, it's taking longer to actually go back to baseline, right? And so it's carrying over, right? It's pushing forward, right? Yeah. And the influence coefficients are just looking at the degree of influence or spillover or carryover, spillover influence in a construct over time, right? And so this is looking, holding stability constant, right? If your partner happens to be, for a 1 unit increase in your partner score at the preceding time point relative to their baseline, how does that predict your own current score relative to your baseline, right? And so this enables us to be able to look at whether or not your partner being especially high at the previous time point has any implications for your current standing on the variable. All right. So we can also take the same latent decomposition approach and apply it to the overtime actor-partner model, okay? But an issue that we need to contend with, right, is whether or not we want to model the within-person portion as concurrent or lagged, right? And so the issue is that I understand that your data set is separated by 7 years, right? We have to think about the time course for the causal effect, right? If we're looking at something like, positive or negative mood, right? I don't anticipate that that's going to actually carry over across 7 years, right? So the kinds of constructs that you might want to see as relevant for this when you have lag variables are constructs that tend to have a slow-moving developmental process, right? If it's fast-moving, it's not going to be as relevant. So what I'm going to show you is the overtime actor-partner model for concurrent effects. Because if the time course is actually very short in duration, right, this is probably going to be more reasonable. And yes, you're going to, not be able to have as much confidence in causality, but it is going to be more consistent, likely, with the time course for the causal effect. And so the first thing we want to do is we can tease apart the between and within person portions of variance for the X's and the Y's for men and women over time, right? And we can actually model an actor-partner model based on the between person portions of variance. And this is regardless if you do lagged or concurrent effects, right? So the actor effect here would just be saying that holding the person's partner's average level of the variable constant, right? If a person has a 1 unit increase in their average level of the X variable, is that related to a certain level of their outcome, average level of the outcome of the other time point? I kind of butchered that, but basically the point is that we're looking at average levels, right? So the actor and partner effects both pertain to those average levels. Now, before I talk about the interpretation of the actor effect here, I just want to bring your attention to the fact that with this overtime model, we're including autoregressive effects for the outcome variables for both dyad members, right? So the autocorrelation non-dependence is being accounted for in the model. And we also have the time-specific similarity covariance between both members' outcome scores at each of the time points as well. Okay. Now the actor effect for X is basically asking what's the expected change in participants Y at time t relative to their baseline for each 1 unit increase in the person's X variable relative to their baseline right there. And so if we're looking at conscientiousness and health promoting behaviors, right, this would be asking if a person is, well, yeah, over 7 years, that's reasonable. If a person's especially conscientious, right, is this transferring over to a person engaging in especially health promoting behaviors, right? And the partner effect is looking at the expected change in the participant's Y variable relative to their baseline as a relationship or as an effect of their partner's level of X relative to their baseline for X, right? So if your partner happens to be especially conscientious, right, are you also engaging in especially more health promoting behaviors, right? And finally, there's the dietic growth curve model. So the previous models that I've illustrated are really looking at fluctuations around a mean, right, for all intents and purposes, right? If you're interested in looking at systematic change over time and you have 3 time points, though, you can model this with the dietic growth curve model. And so if we're specifying this within structural equation modeling, right, we could say that we're assessing men's levels of disclosure at time 1, time 2, and time 3. And we're modeling latent intercepts and slopes as a function of these manifest indicators. And so the intercept is going to have all loadings fixed to 1, right? And the slope variable is going to have loadings that correspond to what you expect for the trajectory, right? 0 is generally, 0 is the, how we interpret the intercept. Okay, so right here it's at baseline. So this would be the person's predicted level of disclosure at time t minus time 1, right? But you can also do it in the middle and you could also do it at the end, right? The other thing is that right now it's 0, 1, 2, right? So this is saying that for, I think it's like 2 weeks apart in my example, for each 2-week increase in time, right, what's the expected change in disclosure, right? Now, if you want to do it yearly, and let's say that you have 0, 7, and 14 years, right, then you can model it 0, 7, 14, and you could look at the expected change for each 1-year increase, right? But again, it's your choice. It's how you want to interpret these coefficients. Now, the dietic growth curve model basically takes those individual growth curves and just specifies them for both people, right? And in addition to that, we're able to model the non-dependence in the people's trajectories, as well as the time-specific residuals, right? And this is interesting because this enables us to look at whether or not these systematic forms of change over time are actually coordinated, right? So if the female in the relationship is increasing disclosure, do we also find that the male in the relationship is engaging disclosure, right? So some concluding comments. Care should be taken to ensure that your research question is consistent with the analysis that you choose. All right, don't just choose an analysis because they're able to do it. Make sure that it's addressing a question that you have. So for example, are you interested in modeling stability and influence? If so, the stability and influence model is for you, right? Are you interested in prospective actor and partner effects? If that's the case, then you can use the overtime actor partner model. Are you interested in coordinated systematic change over time? If so, then the dietic growth curve probably makes more sense to use. So I also want to mention, and I sort of alluded to this earlier, the use of the latent decomposition approach for the cross-lag model with 3 waves and the overtime model with 3 waves, but with lags, right? It should probably only be used with constructs that are known to have a slow-moving developmental process. Because again, what does inertia mean if you're looking at mood when it's 7 years apart, right? So you want to make sure that your constructs are consistent with the model you have in mind. The other thing is that I've only covered manifest variables for focal constructs, but of course with SEM, you can specify latent constructs with multiple indicators. And finally, something that's really important that you can also do with an SEM is that if you're looking at change over time with distinguishable dyads, right, the inferences regarding systematic change are going to depend upon the extent to which your models are invariance across members as well as invariance across time, right? You want to make sure that you're comparing apples to apples instead of apples to oranges. A lot of the time, if we're using multi-level modeling, right, we just sort of assume it, right? There's not really a straightforward way to test that, or that there is a way. But if you have SEM, you are able to test it, and you probably should. Right. So these are some references based on the papers that I referenced. And the next slide actually contains some additional resources. And so the Sekulak, Fisher, and Kilshaw talks about dietic measurement invariance and how to evaluate it. And there are some other resources in here in how to use M+ syntax and other forms of syntax to specify some of the models that I discussed. All right. Thank you.
Thank you very much for the wonderful presentation. And now I'd like to invite the speakers to in front of the room so we can open the floor for any questions and or any like top thoughts for discussions. So if you have any, those of you who are on Zoom, please type in your questions on the chat box. So, and someone will, we are monitoring the chat box so you can, and we will ask the question to the speakers for you. Are there any questions on the Zoom currently? No. Are there any questions in the audience right now? Well, to give them some time to think about the questions, I actually had one question for Dr. Lyons. You talked about like discordance and discordance and congruence between the couples, and I wanted to ask if you could like give us a bit more explanation or examples about how that could be measured. Because some of the papers that I read about these incongruence like was just like simply like subtracting the mean of one partner to the other, but I know that there's a lot of different ways to go about it. So I wanted to ask your thoughts about like different like advantages and ways of like measuring congruence and discongruence.
Yeah, and I think, you know, and I know that it was alluded to actually by the other two speakers as well, but I think you can do everything from just the raw data and a different score. And sometimes you'll see that in these really teeny tiny samples and people are just getting the idea of it. The way it's done in multi-level modeling is to actually to do a gap between them as a latent score, right? And so you are taking, so let's say what I've done, which is symptom incongruence a lot, both people actually report on the same thing. So you have the person with the illness who fills out a measure of pain severity, and then you have their partner fill out what they think pain severity is of the person with the illness. And then you're actually like modeling the incongruence. And there are three pieces of information that you get out, whether you do this in SEM or in MLM, which is you get out the gap between them. So how far apart are they? You get the directionality of who's higher or lower. And then you get something that's really important to sometimes control for, which is the level of the phenomenon, because incongruence can change, as we saw with health. So when you're at the average, let's say health or the average symptom rating within a relationship, if that's low or high, can sometimes actually matter even clinically for how far apart they might be. So if they're far apart, but both of them have no depression or mild depression, that's very different from they're actually really close together, but they both have clinical depression. There's, again, as I said, there's lots of work that's used for response surface analysis, and I know Bill has done a lot of that work in his team for looking at this. So there are lots of different ways, and I think, you know, and I can be corrected here by the more SEM experts, but it's more of a concordance similarity estimate when you're in SEM, just primarily based on the fact, although I have also collaborated with somebody recently where we actually modeled the effect of difference in SEM. So I don't know if you want to add anything to that, but that's usually how it's done, is you're modeling it. And I would always go with the modeling of incongruence and synchrony more than a different score that's raw that you then take into a model. I mean, there are people who are now looking at what is a good death at end of life for a dyad and a couple, which I think is fascinating. That's another dyadic health variable where it's going to be different indicators, and they're doing that outside and then bringing it into models. But if somebody's starting out, I mean, I'm all about encouraging people to move towards dyadic modeling. So if somebody has really small samples and they're just trying to understand it, I mean, a different score is better than nothing, as long as you know the disadvantages of it. Does that help?
Yes, very much. Thank you very much. Are there any other questions in the audience? Yes.
I have a question to Dr. Lederman. Thank you for your presentation, and then you introduced the different types of the methods in dyadic data. And then I wonder, for some methods you explained the requirements. Some methods need at least more than three wave the information, but you did not specify the information whether the common phase growth model or APIM model needs more than 3 time points or not. So please specify that. And also, I wonder whether this method needs some requirements in regards to sample size, whether at least 100 or what's the proper number of sample size. And also, I have a question to Dr. Lyons.
Let's let Dr. Lederman answer
Yeah.
that first, and then we'll come back.
Yes.
Yeah, all right. So the models I kind of described, all of them you can kind of do with 3 waves of data. None of them requires more data, more waves than 3, with the exception that you say if you want to model nonlinear systematic change, then you need more time points, right? So with having 4 time points, you can add another graph curve component and a quadratic component or another intercept or level. And if you have 5 time points, you can add a cubic component. Yeah, so you have more options in modeling nonlinear change. But I mean, the graph curve model is fine with just 3 time points, right? And so the other model, the LAPIM, this is also what Rob kind of provided. I mean, he showed you a slightly different version, but I mean, this is also you can estimate that model with 2 time points. Maybe you need to kind of impose some constraints. You have not all the flexibility that you have with more time points, for example, with the intercept or so. I mean, we also said for the random intercept, you fix all the loadings to 1. Maybe that's an assumption that may not hold in your data. You can free them up. But this depends then on how many data points you have, because with more data points, you can estimate more parameters, right? So then you asked what's the sample size, right? That's a very difficult question. Because I think there's nothing like a simpler rule of thumb. A simpler rule of thumb that you can say. When I was a student, people said, yeah, you need 10 people for each predictor. In an APIM, that would mean, yeah, you can do it with 20 people because you have 2 predictors. And if you have indistinguishable diets, you kind of have 1 predictor only, in a way. I mean, that's too simple. It's also too simple to say, you need at least 100 or so. I mean, that the problem is that we think in these categories. Say, below 100, it's too small. We should have something between 100 and 200. That's good. And some people think you should not use structural equation modeling with 200, with sample size below 200. So what should I recommend? I think it's crystal clear for latent variables. models, you need a larger sample size than if you just have a path. And, you know, the APIM with distinguishing members, you can use regression analysis. So you can use recommendation for regression analysis and having a model with two predictors. But, you know, it's also the quality of the data. Do you have skewed data or, you know, non-linear and non-normal data? Then, you know, you need a larger sample size. So, yeah, I cannot give you a simple answer to the sample size.
Is there a question on Zoom?
Oh, there was another question for
Oh,
Dr.
yes.
Lyons.
Thank you for your answer. I also have a question to Dr. Lyons. I appreciate your presentation. And then one of your explanation, think about this question. This question maybe need the another research, but I would like to add. I just wonder your insights about this question. My question is the whether good relationship in the couples or whether their similar personality affects their health in later life. I wonder the interactions, whether, for instance, the good relationship between the couples with a similar the personality may matter compared to a good relationship in couples who have a different, very opposite the personality may matter. I wonder what's your idea about what is more important in the health outcome.
Well, I don't know what's more important, but I think it's interesting to find out, right? And I think there's going to be a lot of confounds around that, because do we end up in relationships where we're more similar or different in personality? So is there something else beyond the impact of then staying with somebody who is more similar and different? So we probably have to, from a lifespan perspective, tease that out. But I think people, what I've seen with the personality dyadic research lately on older couples is interesting. It's often looking at a relational outcome, you know, in terms of like perceptions of support and marital quality and what are the roles there, and even just gender. So I think the Wong article that was actually presented at GSA a few years ago and is now published, that was really getting at just even this idea of what are the profiles, and they're not all the same and they're not all different. Where do they differ? So they were looking at the big five, and does it matter that you have to be the same on all of them? Or, and again, we don't know. I think this is really a fascinating area of research to understand, but it is, I think, going to be confounded by, do we end up in these relationships, and then do those relationships remain intact depending on whether you're similar or different? So a lifespan perspective on that would be important. I think it's why people are going back to attachment theory. Like when I was an undergrad psychology student, attachment was only talked about in terms of infancy and childhood. Right now, it's become so much more important in terms of when you enter in, which is where I live in my research world, on illness. So when you become the care partner, especially to your spouse or intimate partner, is your attachment style going to impact how that goes for you and for them? I mean, we've even seen it around assisted suicide. Attachment style plays a role in people who pursue assisted suicide. And I used to live in Oregon, where they did a lot of work on assisted suicide there. So I think these types of kind of things that we often think of as very stable over our life in terms of personality and attachment style are coming back into our understanding of what happens when we reach middle age and older adulthood. And I think that's where this life history, or even how many adverse events you've had as a child, you know, where did you get, I love when Amy Rao brought that up, like, where do couples learn how to do this? And do they see this role model? So conflict resolutions, a lot of work that gets done there, but decision making, it's like you get an illness and all of a sudden we think everybody knows how to sit down and make these decisions together. And most of the time in the work I've seen, and probably everybody else, is people stop talking. That's what happens. And I think you're talking about disclosure. I've done a lot of work around that too, and social constraints about whether couples share. And usually they stop sharing. So where are their role models and how do we help the people, and especially when we start doing gender norms and gender differences in comfort level in 1, 2, 3, go, share. And we've seen some really negative impacts in our studies of men sharing. It doesn't have the protective benefit for all men that we're assuming from our dyadic theories. So I don't know if anybody else wants to chime in there. I don't have the answer, but it would be great to find out.
Are there any? Yes.
I really like the discussion on cross-site panel models, just because I've been reading like every new thing that's come out, and it's a really hot thing right now. It's really boring. I can only talk about it here because no one's here. So 2 questions. One, I'm guessing some of the same limitations of a regular cross-site panel model will fall dyadic research too. Would that suggest that maybe a lot of our literature might have overestimated some cross-partner effects or even stability if we're conflating between the effects? So that's one question. And then the other is, have there been a lot of demonstrations of dyadic, more complicated cross-site panel versions? So you showed this random intercept where you allow them to covary across partners. You know, there's other models too. There's like structural residual approaches. There's, I don't think I've seen a dyadic starts model. So one question is, how much should I be worried about this? And the other is, do you have any recommendations from like just good illustrations of using these methods? Anyone can respond.
So one of the things that I've struggled with over recent time is the utility of multi-level modeling for the cross-flagged actor-partner model when you have a small number of waves, right? And so one of the issues that it's funny because different fields are familiar with different problems, right? And so in economics, right, there's this issue they talk about as endogeneity, right? And so the issue is that when you're predicting a score based on a lagged version of the score from before, right, it's confounded with the residuals, right? And so it's like you have the same effect on both sides, right? And what they found is that, you know, if you leave it uncentered, right, I believe that the effects tend to be overestimated. Whereas if you think that person mean centering will get rid of it, right? Well, the problem is now it's confounded with the lower level residual, right? And then the effects in simulations have been shown to be attenuated, right? And so I think with a larger number of waves, that issue sort of dissipates, right? Because, you know, it more so balances. But with a smaller number of waves, I'm not sure. I think with a smaller number of waves, it's useful to use this random intercept cross-lag approach. But, you know, that's also contingent on your sample size. Did you have any?
Yeah, I mean, you must be also aware that every model is wrong. Right? Yeah. Some are useful, right? But there's nothing like all the estimates are biased. We just, as Rob mentioned in his talk, you know, we need to think about what's the research question we want to answer, what's the best approach to answer that question, and then, you know, again, a structured equation modeling has the advantage. It tells you whether you have a good fitting model or not, whether you can leave out, so for example, the C prime path or so, or maybe if you use a random intercept or flagged model, maybe you need to add a growth component, a slope component, or something like that, right? I mean, so that's the only thing I can add to what Rob said.
Have you seen a paper that does that? Add a slope component to
Yes, I saw those papers, but I cannot remember the authors. Sorry, but you know, when I find one, I'm happy to send you the reference.
I believe there's a paper by Lee, Lakrama, and some other colleagues. I can send it to you after this, but they go. Did you cite that one? It's in Journal of Family Psychology. And they actually talk about a variety of models that you can use with dietic data. And one of them is like the latent growth curve with structured residuals. right? But I'm not familiar with any like clear demonstrations in the field of where like that's been the main approach, and this is like the prototypical example. Yeah.
Thank you. Yeah, I think we will have like last question.
So, do you have any thoughts? So, with regard to actor and partner effects, I think many people argue these days that no two effects are truly concurrent. So, when you have both actor and partner effects in the model, some would argue that one precedes or follows. In that sense, having both of them at the same time, and if you try to interpret two effects, one is likely over or under. Do you have any thoughts in terms of the general practice of making actor and partner and interpreting them as you would? I don't know if that sort of makes sense. So the question is related to having a research question or one estimate.
A good question. I have some thoughts, but do you have any?
Go first.
Okay, so I think one of the issues that we need to think more carefully about, just in general, is the time course for our variables, right? And how long it takes one variable to impact another variable, right? Unfortunately, with the cross-like models that I portrayed, and I think Tom portrayed, it's like we're assuming that they're both collected at the same time, and so we're assuming that the causal lag is the same, right? I mean, there could be other ways, I suppose, of testing that, but it just becomes really tricky, right? I think that just in general, there's not enough descriptive work on the time course effects of how things change over time. Because if there was, then I think we'd be in a better position to say that this precedes this, this is when it affects this, right? Meanwhile, you know, any sort of stability or influence coefficient that we obtain from one of these models is going to be contingent on the lag that was used, right? On this interval that was used, right? And it's an open question whether or not that's actually the optimal interval length for that lag.
You know, if I may add, you know, you said one effect is overestimated, the other one is underestimated. Yeah, I think, you know, with the APIM, the problem that we have here is, you know, you have X of member A and you have X of member B, and then you have your outcomes here. You know, so for the after effect, you have kind of the same source, right? My wife reports on the X variable and she reports on the Y variable. And here I report and we have her report. So we have this, here we have shared method variance, we can so speak, right? And here we have different sources for the information. And this is why we can say, okay, the actor effect is overestimated, the partner effect is underestimated. Now, what's the problem then? The problem is it's a measurement issue, right? How we need to have reliable and valid measures. That's very important. If we want to reduce the bias in the estimates, we need to have reliable and valid measures. Very important. I mean, what people have done is they say, okay, instead of a manifest variable, we go with latent. And you can say, oh, I have self-report and partner report. So I report on my own stress, and then my wife says, oh, what's the stress level in your husband, right? So self-report and partner report, that kind of helps to reduce the overestimation in the actor effect and the underestimation in the partner effect. And, you know, I mean, this goes back to, you can also say, yeah, let's use a trait multi-method approach, right? I mean, that would be the ideal, right? To say, yeah, we have multiple traits, we have multiple methods. So here we could say we have two methods, right? Self-report and partner report. And you can also do this for the outcome. And my colleague Ulrich Barth, he did a paper on this. It's in PSPB. And I think it was pointed to by other people about the overestimation, underestimation of the effect. But I think it's, you know, having a good a measure of your variables, both predictor and outcome is kind of the important thing.
Can I just add one thing to that? I agree with everything that's been said, but I think the more we can step back and ask, why are we looking for a partner effect, is important too. I think a lot of times people run an APIM because they have the data and then they're like surprised there's no partner effect.
I think it's mine. Sorry. Yeah. Okay. Yeah.
But I think theoretically, you know, I think people then get really surprised they haven't found this or haven't found that, but then there's no rationale for why did you think you would find one? And so that's not true of anybody in this room, but I'm just saying that I think we read those and we review those papers that are done, and I think that's a proliferation then of people saying there is no partner effect or there's no actor effect without really thinking through the measurement piece of this and the timing piece, which I totally agree with. And then also the theoretical piece of what is it you're doing when you're testing an APIM.
Yeah, no statistics, no models can save you from not asking the right questions, right? That's why I appreciated your talk in theory and just having clear questions that you want to address. Then you can worry about the model after that.
Thank you so much, everyone. I think we are up for time. So this concludes our workshop for today. So thank you again very much for coming. And thank you for your patience while we were like trying to figure out our technical problems in the beginning. So thank you. And I also like to mention that we have a second session of the longitudinal dyadic analysis. And that'll be on March 27th. And it's going to be, we have two experts coming who are talking about how to analyze daily diaries that are collected over time from diets. So please tune in, stay tuned in for that. If you haven't registered, please register, or I hope you can see on Zoom or in person in March as well. So thank you again for the speakers, and thank you very much for coming. Thank you.